All right, let's talk about what next-gen manufacturing really means. We're moving way beyond just making parts here. The idea is to truly master the entire manufacturing process, from start to finish. We're going to dig into how thinking about the whole picture can seriously boost your efficiency and, maybe most importantly, make your tools last a whole lot longer. Okay, let's get into it. So I want to start with a question, especially for anyone who's spent time on a shop floor. What is the single most expensive sound you can possibly hear? It's not the normal hum of the machines or the hiss of coolant. It's it's that one sound that just makes your heart sink. Yep, that's the one. That single, sharp, awful sound. It's the sound of an end mill giving up. And believe me, that sound costs you a heck of a lot more than just the price of a new tool. Because see, a broken tool isn't just a piece of metal that failed. It's a process failure. It means your machine is down, you've wasted material, you might have just scrapped an expensive part. It's a huge blow to the bottom line. And the thing is, it's almost always avoidable. So how do we prevent that dreaded snap? Well, the whole next-gen approach really kicks in long before you even think about hitting that cycle start button. It all starts with really careful, deliberate planning. This is where the magic happens, where you lay the groundwork for a long, healthy tool life. I mean, think about it. There are thousands and thousands of tools out there. You can't just grab one off the shelf and hope it works. You got to do your homework first. What exactly are you cutting? What's the operation? What are the non-negotiable features you need in a tool? Answering these basic questions is how you cut through the noise and find the absolute perfect tool for the job. And this is a fantastic first example, length of cut. You want a tool that's only as long as it absolutely has to be, and not a millimeter more. Look at the difference here. The correct length gives you maximum rigidity, less chatter, and a much longer life. But go too long, and you're just inviting deflection, bending, and that dreaded snap. It's such a simple choice, but it has a massive, massive impact. Now, here's where that deep knowledge really pays off. Let's talk coatings. An AlTiN coating is amazing on a lot of materials, but if you try to use it on aluminum, it's a total disaster. Why? Well, they're both aluminum-based, so they basically stick to each other. You get a built-up edge, chips don't clear out, it's a mess. Knowing these little details is what really separates the amateurs from the pros. And you know, today's tools have some incredible tech baked right in. Take variable helix geometry. All that means is the flutes aren't evenly spaced. This actually breaks up the cutting rhythm, so you don't get those nasty harmonic vibrations that cause chatter. It's a super clever, built-in solution to a problem that's been around forever, and it gives you a much better finish. And please, don't forget this part. You can have the best tool in the world, picked out perfectly, but if your tool holder is weak, it's all for nothing. It's all about maximizing contact and rigidity. Hydraulic and shrink fit holders are absolutely top tier for this. And things like special shank modifications, they add that extra layer of security so the tool doesn't pull out when the cutting gets tough. Okay, so we've picked the perfect tool and we've secured it in a rock-solid holder. Now comes the next step. We have to tell the machine exactly how to use it. We're moving from the physical setup to the digital, dialing in those crucial running parameters. And boy, is this a balancing act. Take spindle speed. If you go too fast, your chips might not clear out, or worse, you could have a catastrophic failure. But if you go too slow, you're going to get tool deflection, a terrible finish, and you're just not removing metal efficiently. There is a very precise sweet spot, and you've got to hit it. The exact same logic is true for your feed rate. Pushing it too hard is obviously a quick way to break a tool, but, and this is what a lot of people miss, being too conservative can be just as bad for the tool. You end up just rubbing and recutting tiny chips, which generates a ton of heat and wears the tool out way faster. That perfect balance is where you find both efficiency and tool life. So, how do you find that magical balance? It's actually really simple. You start with the numbers provided by the people who made the tool. The manufacturer has tested everything. They know every little detail about its geometry and material. Their speed and feed charts aren't just suggestions. They are your absolute best starting point for a successful run. Okay, our setup is perfect. Our parameters are dialed in from the manufacturer. Now let's talk about the strategy while the tool is in the cut. How can we machine smarter to unlock all that potential we just created? It really starts with the fundamentals, right? Climb versus conventional milling. With climb milling, the cutter is rotating with the direction of travel. This makes a nice thick to thin chip. And this is key.
It pushes most of the heat into the chip and away from your tool. For almost everything you do, this means less heat, less wear, and much better tool life. Now, let's level up to a more advanced strategy, high-efficiency milling, or HEM. This is a total game changer for roughing parts. The idea is, instead of taking a big, wide, shallow cut, you do the opposite. You take a much smaller bite radially, but you use a much deeper part of the tool axially, all while jacking up your speeds and feeds. And this really shows you why it's so brilliant. By using the full length of the cutting edge, you're not just hammering away at the very tip of the tool. You're spreading the heat and the wear across a much larger area. This drastically reduces wear, lets the tool live longer, and you remove metal like crazy. It's a win-win-win. And last but not least, let's talk about coolant. It is not just an on or off switch, okay? It is another strategic decision you have to make. For soft, gummy materials, yeah, flood coolant is great for washing those stringy chips away. But if you hit a tiny miniature tool with high-pressure coolant, you could snap it in half. The goal is always to match your coolant strategy to the specific job you're doing. So, what does all of this add up to, It's not just a random collection of tips. It's a whole philosophy. It's about thinking through the entire process, from the very beginning to the very end. This is what we call the next-gen machinist mindset. When you boil it all down, it's really about these 4 principles. First, you plan. Be meticulous with your prep and tool selection. Then, you calibrate, trusting the expert data from the manufacturer. Next, you strategize, using smart techniques like HEM. And finally, you adapt, using every tool in your arsenal, including coolant, in the smartest way possible. That is the path to better efficiency and longer tool life. Look, the tools we have access to today are absolute marvels of engineering. They are smarter, stronger, and more capable than ever before. They're packed with technology that's just waiting to be used. So the only real question left is, are your strategies smart enough to unlock all that potential?